the industry standard, or at least what we generally see as far as leak detection systems when we approach a new client, especially maybe a mid-sized operator, would be they have some level of understanding of the kinds of regulations that they need to meet, the kinds of capabilities that a leak detection system needs to provide, but they don't necessarily know how to get from the measurements that they're already taking, flow measurements, pressure measurements, temperature measurements on their pipeline, how to translate that into actionable intelligence that they can use for leak detection. What we see a lot of the time is that they'll take their measurements and they'll try to do kind of like a fairly simple volume balance, comparing the flow that goes into the pipeline and comparing that against the flow that comes out of the pipeline. And if there's a deficit there, then that's probably indicative of a leak somewhere along the pipeline. But there's all sorts of kind of real world complexities that arise when you start implementing that, things that aren't necessarily obvious on the surface. How do you deal with, startups and shutdowns or transients or pump speed changes and stuff like that? My name's Chris Johnston. I'm the Director for Research and Product Development for Pipewise. My background is mechanical engineering originally. I have worked in research and product development for the last 9 years at this point, developing out-of-the-box solutions for oil and gas challenges. My specialty is in fluid simulation, fluid modeling, and at Pipewise I use that as part of our CPM and our research there to understand how fluids and pipelines behave to be able to develop new solutions for leak detection beyond what's currently available on the market. So if you're talking about leak detection fundamentals, really what it comes down to is a form of anomaly detection. We've got a line balance across a pipeline and we're trying to identify when there's a deviation in that line. Is that due to a leak or is it because of something else? It's easy to look at the flow coming into the pipeline and the flow coming out of the pipeline and seeing that there's an error there. But what's really difficult is understanding when that error actually means that there's a release of product somewhere in the middle, or is it because of any number of other factors that can screw up a line balance? So when we talk about the metrics associated with leak detection, it generally comes down to 4 that you'll typically find in most of the guidelines that are in things like CSA Z662. What we would be looking at there is going to be reliability, accuracy, robustness, and sensitivity. And each of those kinds of plays a role in understanding how a leak detection system of any kind is going to perform in different kinds of conditions. When we talk about accuracy of a leak detection system, really what we mean is this going to be able to find leaks? If there's a 1% leak, if there's a 2% leak, is the system going to be able to pick up on that? Every system is going to have a threshold. For example, probably won't be able to find a 0.1% leak on a pipeline, but as that leak generally gets a little bit bigger, as maybe the pinhole starts to expand a little bit, you want to be catching that as soon as possible. The second one that I would talk about is going to be robustness. How does the system deal with really edge case scenarios? If you have a comms outage, how does the system deal with that? If the cell connectivity suddenly comes back, how does the system deal with that? Is it instantly going to flag an alarm? If you've got, maybe you bring a new pump online or your volume imbalance gets out of whack because of an operational change, how does the system handle that? There's all kinds of interesting edge cases that show up. And this is really one of the big things that at Pipewise we see lacking is the robustness aspect when it comes to kind of these home-built or purpose-built SCADA system solutions that a lot of companies might initially implement as a first try at leak detection, because we've seen so many of these different edge cases across different pipeline sizes of different complexities. So we can really help in that kind of role to be able to deal with those sorts of events. The third one that I would talk about is going to be reliability, and that ties into the false alarm rate. So how frequently is the system alarming compared to what your actual leak rate is in a given month? How frequently are your operators going to be dealing with those false alarms? Because that can definitely create additional workload for them with having to manage that, or eventually, worst case scenario, it just turns into operator fatigue where they start to ignore that entirely. Sensitivity, and that's going to be tied to the leak characteristics. So when we talk about leak characteristics, if the system alarms, we're going to be saying you've got this kind of a leak, so you've got this size of leak. If we're saying you've got a 0.6% or a 1% leak, how close to accurate is that? Is it actually a 1% leak or is it actually a 5% leak? Because your response plan and the steps that you would take to deal with that could look very different if you think it's a 1% leak versus a 5% leak. Similarly, if we're predicting where along the pipeline that the leak is occurring, that's going to be tied into the sensitivity as well. So are we saying that it's occurring in kilometer 5 of a 100-kilometer pipeline? That really narrows the search space of where you're going to be trying to mobilize your assets to deal with that. And all 4 of these metrics work in tandem to make sure that you have a leak detection system that you can trust. We've seen such a range of different complexities and different challenges, everything from very simple point-to-point pipelines, but maybe with inadequate meters or inadequate instrumentation, bad data reporting frequencies, correction factors that need to be applied because you're getting offsets in your measurements, all the way up to large networks, multiple nodes, multiple inlets and outlets all into the same network. We've pretty much seen it all at this point, and we're ready to help customers improve and advance their leak detection systems that they've already started on, or that they might already have in place, and being able to help advance that to the point where they can detect the leaks that they're looking for. Everybody generally has a target or a leak size that they want to be able to get to. Maybe it's 1% of the flow, maybe it's 2% of the flow differential, and we sometimes those targets are achievable with the instrumentation that they have in place, and sometimes it's not. What Pipewise can provide is that expertise based on our experience working with dozens of operators across multiple different systems of different scales and complexities to help people understand what is an achievable leak detection threshold, what is your system fundamentally going to be capable of based on the product type, the data, frequency and reliability, and if it's not meeting the thresholds that you're looking for, what can be done to get it to there? So what needs to be done, or what additional capabilities need to be added into the system to be able to meet not just your regulatory and compliance needs, but your peace of mind as well, making sure that it's getting to the threshold and the performance that you're looking for.